This is the second part of our video on section 4.5. Notice how we have two pairs of congruent sides here, and we have a pair of congruent angles that aren't included. It's the same pair of arrangement of parts as side angle side, except with the angles not being included, see how the angle is on the other side of the sides, the pairs of congruent sides. So we call this the SAS postulate. It is not a congruence postulate because it does not force the two triangles to be congruent to each other. This one is way smaller than this one. So that SAS postulate is not a valid method for proving that the triangles are congruent. Although there is a special case when the triangles are right triangles. And that's what we're going to look at in this video. So before we do, you need to make sure you remember the parts of a right triangle. When you have a right triangle, the sides that touch the right angle are called the legs. And the side that doesn't touch it, that's the longest side, it's called the hypotenuse. So here's two triangles. They are congruent to each other. They have a pair of congruent sides, and a second pair of congruent sides, and a pair of congruent angles that are non-included. That is the SAS postulate, with one difference. The congruent angles are actually right angles. When the congruent angles are right angles, that forces these two triangles to be congruent. So in general, that SAS postulate does not prove the triangles are congruent, but if the angles are right angles, it does. So instead of calling this the SAS postulate, since it doesn't work most of the time, we're going to call it the HL congruence theorem. And the reason we do that is we have congruent hypotenuses and we have congruent legs. When that happens, your two triangles are congruent. So if you're going to use the HL theorem in a proof, here's what you got to show. You have to show that you have right angles. That's important because HL doesn't work unless you have right angles. You also must say that you have right triangles. Once you do that, show that you have congruent legs and congruent hypotenuses. So even though there's two letters here, it might seem like it's quicker to use HL than it is to use side angle side or side side side, but you actually have to do one more thing. So let's use the HL theorem here. We're given that segment WY is congruent to segment XZ. And I'm not going to mark that on here because notice how these segments cross. So what I could do is separate my triangles. This is probably the smartest thing to do. That's triangle WZY. Here's triangle XYZ. Mark these parts congruent. Also, they're telling you that these two segments are perpendicular and these two segments are perpendicular. So here's a separated picture with your given information on it. I'm going to start by writing the congruent statement that's given to me. And then I'm going to write the other two pieces of information that's given. I'm going to write them together with each other because they're both talking about perpendicular segments. But I'm going to keep them separate from this congruent statement because these are not congruent statements. What does it mean if things are perpendicular? If they're perpendicular, then that means you're going to have right angles. So when you see a symbol or a term, you need to define that. Where exactly are these right angles? I'm going to use three letters to name this angle Z, because if you look in the original picture, naming an angle Z is a bad idea. Z is a vertex for three angles there. So I'm going to say angle WZY and angle XYZ. Are right angles. That's what perpendicular means. Now, if you look at your triangles, you have some congruent sides and you have some right angles. We didn't say they're congruent yet, but we could if we needed to. It's important to know if we need to say that these are congruent angles or if we need to say that these are right triangles. I would need to say that these are congruent angles if I'm going to use side angle side. If I'm going to use HL, I need to say that these triangles are right triangles. So I kind of need to know right now which direction I'm going. This segment ZY is on both triangles. So that's going to be your third pair of congruent parts. So you don't have to say this next, but it probably makes sense to have that figured out before you go in a different direction. So segment ZY goes with segment, watch the order, YZ. That's the reflexive property. Now, at this point, I think you can see that these aren't congruent by side angle side, but they are congruent by HL. You have congruent hypotenuses and congruent legs in right triangles. So you need to say that these two triangles are right triangles. So make sure you say triangle WZY and triangle XYZ are right triangles. How do you know they're right triangles? Well, you already know they have right angles. That's the definition of what a right triangle is. If it has a right angle, it's a right triangle. So at this point, we have our congruent legs. We have our congruent hypotenuses. We have right angles. We have right triangles. We can say that the triangles are congruent. And they're congruent by HL.